So, good morning, friends. I am Kundan, and today I am going to discuss the limit problem. This is the most favorable question which can be asked in board exam or you can say mains problem. So, let us evaluate this question. So, in this case, this is simple bracket, curly bracket, and this represents the greatest integer function. So, since we know that greatest integer of x plus I, where I is integer, is nothing but greatest integer of x plus I. That means if greatest integer of x plus 2 is equal to greatest integer x plus 2, means whatever the integer in the greatest integer box which comes as it is outside the box. That means greatest integer, let's say greatest integer x minus 5 is nothing but greatest integer x minus of 5. So according to this, here 1 square is natural number, 2 square natural, 3 square is natural and integer, so we can put it out of the box. So this will become limit n tends to infinity 1 square x plus 1 square, 2 square x plus 2 square, and so on, n square of x plus n square. This is your now what we have to do, we collect all the greatest integer term one side, 2 square x and so on, n square of x plus this will become 1 square plus 2 square plus and so on plus n square. These are our remaining problem. ठीक है. Now we know that greatest integer का ये property है कि greatest integer of x is less than strictly greater than x minus 1 and less than equals to x. That means greatest integer of 2.5 is strictly greater than 2 minus 1 and less than equals to 2.5. Means 2 minus 1 means 1. Sorry, 2 minus 1 is 1 less than equals to 2.5 greatest integer or less than equals to 2.5 means this hold. So we applying this formula on this. So now what we are going to do, this means 1 square of x greatest integer is strictly greater than 1 square of x minus 1 and less than equal to 1 square of x. In the same way, 2 square of x is strictly greater than 2 square of x minus 1 and 2 square of x, and so on. This applies we have to n square of x strictly greater than n square x minus 1 less than equals to n square of x. So apply this in the this. So we will limit n tends to infinity. Now distribute 1 over n cube to the both term. This will becomes 1 square of x minus 1 plus 2 square of x minus 1 and so on up to n square of x minus 1 divided by n cube less than equals to limit n tends to infinity. You have 1 square of x plus 2 square of x and so on up to n square of x divided by n cube, which is less than equal to limit n tends to infinity 1 square x plus dot 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 n square of x divided by n cube. Now take the common out. This will become 1 square plus 2 square and so on up to n square x minus n, चूँकि -1 up to n times, so this will become minus n divided by n cube. Okay, divided by n cube, and this less than equals to limit n tends to infinity as it is, and n square of x divided by n cube. And since this is a take x common out, so this will become sum of square of n first natural number. So this will become first natural number. Apply the sum of square of first natural number to the both terms, so it will becomes n into n plus 1 into 2n plus 1 divided by n cube into x minus n divided by n cube. This limit as it is. This limit as it is. Apply the first natural number sum of a square of first natural number formula 2n plus 1 divided by 6 over n cube into x. Now take the n common out from 3 bracket. This will becomes and cancel. Take common out and cancel, so it will become 2 plus 1 by n divided over into x limit n tends to infinity. This will become limit n tends to infinity. Distribute the limit 1 over n square. This is as it is limit. This will becomes limit n tends to infinity. N 1 into 1 it cancel out, so it will become 1 plus 1 by n. This will become 2 plus 1 by n into x divided by 6. Put the limit n tends to infinity, so it will become 1 into 2, here divided by 6. Here divided by 6 also come na, divided by 6. So this will come, and since 1 over n square as n tends to infinity 0, the evaluated limit, this will also become 1 into 2 divided by 6 into x. Now, so our problem is, this will becomes x by 3 less than equals to limit n tends to infinity 1 over n cube 1 square x plus 2 square and so on, n square of x divided by n cube less than equal to x by 3. So by sandwich theorem, the limit of the function is nothing but limit n tends to infinity 1 over n cube 1 square x 1 square x plus 2 square x and so on, plus of n square x is nothing but x by 3. So the limit of this function is nothing but x by 3. Now we have evaluated the limit of the function, limit of this function we have evaluated x by 3. Now we have to evaluate the limit of this function. So since we have to distribute n cube this 2 and the n cube, we have to take the n cube this side also, no? Because distributive will occur. So now we have to evaluate the limit of this function. The limit n tends to infinity 1 square plus 2 square plus dot plus n square divided by n cube. Apply the sum of first n natural number square, so it will become n into n plus 1 divided 2n plus 1 divided by 6 into n cube. Take the n cube common out, so it will become 1 plus 1 by n 2 plus 1 by n, and take the limit as n tends to infinity, so it will become 1 dot 2 divided by 6, that means 1 by 3. So the overall limit of the function is nothing but, now we have to put the limit of this both function, so limit of this function is nothing but x by 3 and the limit of this function is nothing but 1 by 3. So the required result is limit of the function is x by 3 plus 1 by 3. Okay, thank you for watching the problem.